Welcome back. So we have all of today to work on the chain rule. We'll just continue working on these ones. Maybe we'll do these ones together. Specifically, I do want to talk about this one because there's a common mistake that students make on those ones, and then we'll just do some more problems. Lots of problems, lots of fun problems. And maybe even more problems, who knows? So this most recent one, so B, H of W is equal to the sine of cosine of W squared plus 1. So that is a chain rule within a chain rule. So we have to do two chain rules. And they happen at the exact same time, but you usually, the way I like to figure that out is I go, okay, so H prime of W. So you take the derivative of the outside function. That's how it always works. So the outside function here is sine. The derivative of sine is cosine. So it's cosine of the inside. So cosine of W squared plus 1 times the derivative, so ddw, of cosine of W squared plus 1. That's me showing all the details. If you feel comfortable going straight through each step, go right ahead. But either way, so now we have to take care of that ddw of cosine of W squared plus 1. So the outside function there is cosine. So the inside derivative, so the outside's derivative would be negative sine. So we can either do that all at the same time, or we can do this off on the side. This will be negative sine of W squared plus 1 times the derivative of the inside. So you can do it in steps, or you can do it all at once. It does, like, as long as it's making sense to you, I'm indifferent. And then the derivative of W squared plus 1 is just 2W. So at the end of the day, H prime of W is cosine of W squared plus 1 times, I'm actually going to I'm going to do something different. I'm going to put the negative 2W out front. So this negative sign here, this 2W right here, and then cosine of W squared plus 1, and then sine of W squared plus 1. What you will eventually get to is you'll be able to look at this problem. I'm going to redo it right below it. You don't have to write this down, so I'm going to write it in brown to symbolize that I don't want you to write this down, but H of W equals sine of cosine of W squared plus 1. Eventually, what you get to the point of doing is you just do it as you like just like with the product and the quotient rule, you kind of do it as you write it, instead of like trying to break it up into pieces and take care of it. Every once in a while, you will need to take a step back and break it down into pieces. But for something like this, it might get to the point where you feel comfortable going, okay, so the derivative of the outermost function, cosine of the inside, cosine of W squared plus 1. And then now I'm looking at the inside. The inside derivative of cosine is negative sine. So times negative sine of W squared plus 1 times the derivative of the next inside, which would be 2W. That's the way you get to the point. You get to that point as you go along, where you can just do it in one step. Do you have to do it that way? No, absolutely not. But it makes it somewhat easier once you get to that point. The one thing I will note, though, is if you do it this way, please remember to include your parentheses. Because if you do this, it looks like it's cosine of W squared minus 1, W squared plus 1 minus the quantity sine of W squared plus 1 times 2W. It doesn't look like it's multiplication. So please put those parentheses there. Okay, any questions on that one? So that's a double chain rule. Next, this one always throws students off when they first see it, because we're so used to saying that the derivative of the exponential function is itself, which is true, but that's just as a reminder, so don't write this down, d dx of e to the x is e to the x. Not d dx of e to the x cubed minus 7x squared plus 2, whatever it is. So with that, it requires a chain rule. The outer function is e. The inner function is x cubed minus 7x squared plus 2. So when you're doing the derivative here, k prime of x, the outer function is e. The derivative of e is itself. So e raised to the inside, so e of x cubed minus 7x squared plus 2 times the derivative of the inside. The derivative of e to the x cubed minus 7x squared plus 2 is not just itself. You have to take on that additional derivative of the inside. So the final answer should be that k prime of w is 3x squared minus 14x times e to the x cubed minus 7x squared plus 2. Any questions on that? If there are. The exponential function, its derivative is itself, but that's not e to the x, that is e to a quantity. So if you want to like write a rule or whatever, if that helps you, d dx of e to the box is equal to e to the box times d dx of the box. So it's the derivative, maybe that makes it more useful, maybe it doesn't, but you gotta rewrite the function again and then multiply times the derivative of the inside. You're looking concerned. In this diagram here. Oh, I don't know why I wrote W. I don't know why I wrote W. Should be an X. Thank you for catching that. Thank you for catching that. Okay. Any other questions? All right. I wrote it here as a reminder for this most recent one. Just as a reminder, you're not going to be tested like you could be tested on it, but I will provide you the derivative rule for non-bases, non-natural bases. So the derivative of a to the x is natural log of a times a to the x. So in this case, t prime of y, the outermost function is pi to the something. So it's going to be natural log of pi times pi to the cotangent of y. That's the derivative of the outside function evaluated the inside. The outside function is that exponential function with the base of pi. And then you evaluate it inside. That's why it's pi to the cotangent of y. And then we need to multiply by d dy of cotangent of y. By the way, if you don't like writing the d dy's, you can also write this, a prime symbol like that, if that makes more sense to you, or if you don't like to write the d dy, but however you want to do it is fine. So the derivative of cotangent is, yes. You don't have to have memorized. I'll provide it for you if it ever shows up. So yeah, you don't have to memorize it, but like knowing how to use it might be useful. So d dy of cotangent of y. I always look back to tangent. I don't have the cotangent, the cosecant, or the I have the cosine memorized purely because you use it so often. But cotangent and cosecant, I don't have memorized. I just try to remember secant. The derivative of secant is secant tangent. The derivative of tangent is secant squared. So the derivative of cotangent will be negative cosecant squared. This right here is negative cosecant squared of y. So the final answer should be that t prime of y is negative natural log of pi times pi to the cotangent of y times cosecant squared of y. You can keep the negative sign with the cotangent, but just make sure you put it in beautiful. However you want to write it though. So I'm putting that negative sign for negative cosecant squared y at the beginning. Right. Any questions on that? Let's try to do the next one. Try and do it yourselves. I'll slowly fill in details. As a reminder, the derivative of natural log is 1 over x. So the derivative of this is 1 over the inside times the derivative of the inside. Plus. Try it yourselves. By giving you that little duckling push off the tree, or a bird off the tree. Go fly. Yes. So dy dx is a derivative, ddx is taking a derivative. Does that make sense? So dy dx is the derivative of y, whereas ddx means you're taking the derivative of whatever's on the inside. Got the answer up here if you'd like to check your work, but if you're still working on it, continue to do so. And we will talk through this one. This one's a little challenging at first, but it brings up a very, very good point about these things. So derivative of natural log is 1 over the inside times the gee, go ahead.
Distribute the negative.
We could, yes, absolutely. Excellent question. So at the end of the day, we could distribute it, but since we're not asked to do anything with our derivative, we could leave it that way. But it's not wrong to distribute the minus sign. Give you full credit either way. I wanted to do that, honestly. I wanted to distribute it, but I was like, Maybe I should hold off on the algebra for a second, especially since this one's something we haven't encountered before, because this one is a chain rule with a product rule on the inside. So the derivative of natural log is 1 over x, but this is natural log of 7x to the 5th minus 4e to the x cosine x. So it's 1 over the inside. So 1 over 7x to the 5th minus 4e to the x cosine x times the derivative of the inside. And so the first piece, the first term, nice quick derivative, 35x to the 4th. But the second term is a product rule. The second term is a product rule of 4e dx and cosine x. So you have to do the product rule, f prime g plus g prime f. F prime, the derivative of 4e to the x is 4e to the x. The derivative of cosine is negative sine of x. So f prime g plus g prime, which is negative sine of x times f, which I simplified by taking care of the minus sign. Writing is 4e to the x cosine x minus 4 to the e to the x sine x. So, yes, Rob. Because it's a product of two functions. So that's an interesting observation that in this case, you could just, well, the problem is you still have to take care of the product rule. It's like, if you were to just ignore this and leave it out front, then you just have the derivative of cosine be negative sine. So you'd be missing out on another term. So you have to do the product rule here. Any questions on that? Any other questions? All right. So point being is that you can now have a chain rule of a chain rule, or you can have a chain rule with a product rule on the inside, or a chain rule with a quotient rule on the inside, or a chain rule with a chain rule with a chain rule with a quotient and a product rule and a chain rule all together. You can have so many different, there are infinitely many combinations, which can be daunting, but also pretty fun. There's so many different problems that you can solve. So the next one, e to the cosine of x cubed. That's a double chain rule because e is the outermost function, and then the second most outer function is cosine. So go ahead and do that. Go ahead and do that. I'll slowly fill in details. Get the answer up here if you'd like to check your work, but if you're still working, continue to do so. Okay, if you're not as fast as me, once again. On a total aside, because it got brought up, like someone had mentioned it. If there's any Paramore fans or any Olivia Rodrigo fans, there's a mashup of the two songs, Misery Business and Good For You. It's amazing. It's like better than both combined. Highly recommend. Just search on YouTube, Olivia Rodrigo, Misery Business, and the mashup is amazing. You won't even realize they're two different sides of the same issue that's happening. One person's stealing another person's. It's great. It's great. 100%. Love it. Not that I listen to either of those bands, but anywho, so this one, chain rule within the chain rule. The outermost function is e, so the derivative of e to the x is itself, but this is evaluated at the inside function, so it's cosine of x cubed times the derivative of cosine of x cubed. And the derivative of cosine x cubed is negative sine of x cubed times 3x squared. So I just rearranged it in a way that I thought might be prettier. I probably should put the sign in front of the e, but I decided to do it differently. Preston, yes.
Negative in front of the sign instead of.
If you left it like just right here, yeah, that's fine. And Chris,
Is the derivative of x cubed not 3x squared?
it is.
Oh,
I moved it, yeah, I moved it to the front. All right. So these ones right here, these three problems here. Do you notice? So let's look at R of t is going to require a chain rule, right? Because it's the outermost function is natural log and the inside is a quotient. So this will require a chain rule with a quotient rule. Part B, that's going to require a chain rule with a chain rule on the inside because you've got q cubed minus 4 to the 1/2 power. And then the bottom one has a chain rule because the outside function natural log. And then you have another chain rule with a quotient rule on the inside. That seems pretty complicated, but if you remember something about logarithms, recall the three important facts about logarithms. You guys remember them? Log base b of m times n is log base b of m plus log base b of n. Move that back a second. Two log base b of m divided by n is log base b of m minus log base b of n. And last but not least, log base b of m to the r is equal to r times log base b of m. You guys remember those rules? Logarithms? Should, because logarithms are awesome. Logarithms are the best part of 126. 100% my favorite part of 126 is talking about logarithms. They're just so fun to mess around with. So, and hopefully your teacher taught you about the quick trick on expanding these things is just anything in a numerator is added, anything in the denominator is subtracted. We'll see that when we get to logarithmic differentiation in about 1 to 2 classes. So that rule, the reason why I mention it now is that now this right here, this first one, R of t could now be rewritten as natural log of sine of t minus natural log of t squared plus 1. Which, yes, it's now 2 chain rules, but it's now just 2 individual isolated chain rules that don't require anything else besides just taking the derivative of a somewhat nice function. So it allowed us to kind of bypass some stuff. It would not be wrong to find the derivative of it using the chain rule and then a quotient rule. It would not be wrong to do so. It's just unnecessary extra work. So r prime of t is 1 over sine of t times cosine of t. Make sure you understand where that came from. Soft and side note land, so let's put a little bubble around it. The second one is going to be minus 1 over t squared plus 1 times 2t. Take a second to make sure you digest why that's true. I kind of skipped writing the ddx here. I usually only write that ddx of the inside if the inside is going to be complicated. The sign is not complicated, quote unquote. Complicated-ish, but not something like the previous one where it was like this one here. That one is a little more complicated of an inside, so that's why I actually did the ddx step. If you feel comfortable just jumping ahead, go right ahead. So the reason why Natural log of sine of t is 1 over the inside. Natural log is 1 over x, but this is natural log of sine of t. So 1 over sine of t times the derivative of sine of t, which is cosine t. Same thing for the natural log of t squared plus 1. That'll be 1 over t squared plus 1 times the derivative of t squared plus 1, which is 2t. We could leave it like that, or we could be all fancy schmancy and know that cosine over sine is cotangent. So you write this as cotangent of t minus 2t over t squared plus 1. The next one is, I did it deliberately. So I used to teach, when I was a grad student, they basically always put me into the business school calculus class, which is a really, really simplified version. Because business majors are stupid. All right, badooks. Kidding. If anybody's a business major, why would you do it? No, you're smarter than I am, because that's probably going to make you more money. But anyways, the business calculus ended up, they don't, in the business calculus, they don't go over derivatives of exponential functions. They don't go over derivatives of trig functions, inverse trig, anything like that. It's basically just polynomials. But one of the things that is different about it, you learn a couple other things, but a lot of their functions deal with supply and demand, and they're talking about quantities. So they always use the variable Q, which not many people like because it starts to look like a 9 if you're not writing it carefully. But you get the opportunity to say Q cubed, which just say it in your mind and it scratches an itch for you. But trust me, it's a Q cubed. Just go ahead and say it, Q cubed. It's very, very fun. So whenever there was a problem on an exam or on a homework problem that had a cube in it, it's a good day. When you're in grad school, not many days are good days. So if you take them where you can get them. This one right here, just as an aside, this is Q cubed minus 4 to the 1/2. And so that 1/2 power can be brought out front. So this is the same thing as 1/2 log base 5 of Q cubed minus 4, which makes it a lot easier to deal with. And I will be saying Q cubed as many times as I can. So C prime of Q. Now I don't expect you guys to memorize it because it's not required, but the natural log's derivative is 1 over x. Log base b is 1 over log base b. So, I mean, we can write it down over here. ddx of log base b of x is 1 over natural log of b times 1 over x. So here, that 1/2 is a constant, so it can remain out front, times 1 over natural log of 5 times 1 over x. But in this case, since it's a chain rule, it's the inside function. So Q cubed minus 4 times the derivative of Q cubed minus 4, which the Q cubed has a derivative of 3Q squared, and the minus 4 has derivative of 0. So that Q cubed has a 3Q squared derivative. And so we can simplify it, because that gets us to say it at least one last time before we say goodbye to it. C prime of Q is equal to 3Q squared, all divided by 2 natural log of 5 times, say it one more time with me, guys, Q cubed minus 4. Make sure your Q's have a tail, by the way, otherwise it starts to look like a 9 and it can become super confusing. By the way, once again, you can do this without having to do the rules of logarithms. The reason why I bring it up now is to remind us of this fact when it comes to logarithmic differentiation, because with logarithmic differentiation, we will want to use these properties a lot. So definitely trying to get us to say, oh, I remember this process. This one here, this is the same thing as natural log of 2e to the 3x plus 1 to the 1/2 over 7x minus 2 to the 1/2 Granted, you could just bring out the 1/2 all the way at the beginning, but I like to do it this way. So that is 1/2 natural log of 2e to the 3x plus 1 minus 1/2 natural log of 7x minus 2. The trick about the logarithmic rules is that anything in the numerator is positive or added. Anything that's in the denominator gets subtracted. So the derivative of this, f prime of x, is 1/2, that sticks out front, times the derivative of natural log, that's the outermost function. So that'll be 1 over 2e to the 3x plus 1 times the derivative of the inside, which will be, I want you to try and figure it out for yourself without doing the ddx thing. I want you to be able to figure it out. It should be 6e to the 3x. The reason for that, you got that 2 that's going to stay constant. The derivative of the e to the 3x will be e to the 3x times the derivative of 3x, which is 3. That's why it is 6e to the 3x. But you can verify for yourself if you want to on the side. And then minus 1/2 times 1 over 7x minus 2 times 7. Because the derivative of 7x minus 2 is just 7. And you can leave it like that, or you can simplify however you want to do it. Since we're not asked to actually do anything with this derivative, we can leave it as is, or we can have some fun and simplify. The minor things we can simplify. And cancel the 2 and the 6 a little bit, but I'm just fine calling it quits here. Been a long exam. I'm just going to call it good there. Phil can figure it out on my exam. This actually makes it way easier to check your answer. So, any questions on that?
The second one would reduce, or the second one would reduce to 7 over 14x minus 4, correct?
Yeah, you could do that. Yeah. Mm-hmm. All right. Any questions on that? All righty. Now let's do, so these two problems, I want you guys to work on them. I want you guys to figure them out. I'm going to come around and help anybody who wants a little bit of guidance. I'm actually going to pause the recording so that's not just for people watching the recording, they're just waiting for the. Okay. Just going to get this one started in case you haven't got it figured out yet. So. So outermost function is that 7th power. So 7 inside to the 6th power times the derivative of the inside. And that's going to require a quotient rule. And then if you're working on the next one, I saw several students make the mistake, and it's okay. That's what I was expecting for it. You got to remember that this is a product of two functions. So this is your f, and this is your g. So I'm going to pause the recording again, kind of walk around. I'm not going to switch off the first one. So that's going to be, so this is my f, and this is my g. So f prime of x is going to be 7 times x squared plus 1 over x cubed plus 2x minus 3 times the derivative of the inside function, which would be a quotient rule. So 2x times x cubed plus 2x minus 3 minus 3x squared plus 2, that's derivative of g, times x squared plus 1, that's f, all divided by the denominator squared, x cubed plus 2x minus 3 squared. And we do not need to simplify it any more than that. Please don't, because then I have to figure out whether or not you made any mistakes. Oh, and there should be a sixth power. Forgot that. And so for the second one, I'm going to write down the derivatives. F prime should be e to the 4x squared times 8x, because chain rule, derivative of the outside function, e is itself, but it's evaluated at the inside. So e to the 4x squared times the derivative of 4x squared will be 8x. And then g prime, derivative of tangent, because that's the outermost function. Derivative of tangent is secant squared. So it's secant squared of natural log of x times the derivative of natural log of x, which is 1 over x. And then from there, we should hopefully get it. If you don't, actually, I'm going to finish this one off. So y prime, or dy dx, is f prime. So 8x e to the 4x squared times tangent of natural log of x plus g prime, which I'll write as secant squared of natural log of x all over x times e to the 4x squared. However you want to write it, though, as long as it's got all the pieces properly multiplied together, you should be good. Any questions on those? I'm recording, right? Good. The worst feeling. I've had it happen twice. I didn't record an entire 2-hour lecture. It's like, I'm not going to sit down for 2 hours and re-record it. Luckily, I was teaching the same class, and so I just copied their recording. But any questions on those? I think that's the last one. Okay, so let's go ahead and take a little break. Let's take a break until 10:20. Or do you want to just get out 5 minutes early instead, or 10 minutes early? That'd be better. You want to keep, are we okay keeping going? Break? I'm happy to, like, I think a break would be nice. So we'll take a little break. All right. So we've done a bunch of practice, and now let's also do a little bit conceptual. It's a very, very similar problem. This one, you're given information about F, G, and H. So G and F, you're given their graphs. Like if there's multiple graphs on a problem on an exam or a quiz, hopefully this is clear enough. Is this clear enough on how the graphs are presented? I hope that's okay. I'll try. Like, I also have the option of doing dotted lines, which have less space in between this the hash marks. So, but I don't want it, like, on an exam, it's all black and white. So I don't want it to be like 2 black lines at the same time. So anyways, but this one, so find d dx of f of h of x at x equals 1. So this one, very, very similar. Except instead of being like going back to 2.3 for just a moment, it's very, very similar to this problem, right? Where are you? No, it was earlier than that. There we go. Very similar to this one, where you had to do the derivative of f over g, where you don't know the equation of f or g. You just need to appeal straight to the definition. And I bring that up because that's a very classic math move that you want to learn how to do, is if you don't know how to figure something out, try and see if you can relate it to something earlier that you've seen before. So we've seen that problem, so we just apply straight to the definition. By definition, this would be f prime of h of 1 times h prime of 1. That's worth, if this is a 4-point problem, that's worth 2 points right there. The next 2 points come into play. How do we actually evaluate this? Well, the good news is h, we already have all of its values that are needed. So h of 1 by the information given, h of 1 is -1, and h prime of 1 is equal to -1, and h prime of 1 is 3. So what we have is we have f prime of -1 times 3. And so the last thing to do is to figure out what f prime of -1 is. And a classic mistake students will make is they will say that f prime of -1 is 0. Because f prime of -1, we're looking at the tangent line there, not f of -1 is 0. But f prime of -1 is this tangent line, which has a slope of -1. M tan is equal to f prime of -1, which is -1. Just so happens that ends up being the same. So this will equal -3. Super cool problem though, right? You got all this stuff that we can take in this information and figure things out. Similarly, if k of x is equal to g of sine of x, find k prime of pi. So, and then we want to find the tangent line to the curve at x equals pi. So, first things first, when you're talking about a tangent line, you need a slope and you need a point. So, for slope, we're going to be looking at k prime of x. Now, g, we don't know the equation of it. So, we're going to have to just look at this straight up as a definition. G of sine of x would be a chain rule. So, it would be g prime of sine of x times d dx of sine of x. That is to say, k prime of x is g prime of sine of x times cosine of x. So now that we know what the derivative is, yes, it's looking weird because we don't have, like, it's got this g in there, but we have the curve g. We don't know its equation, but we can find tangent lines. So k prime of pi would be g prime of sine of pi times cosine of pi. Cosine of pi is -1, and sine of pi is 0. So this is the same thing as g prime of 0 times -1. And for g prime of 0, we're going to have to refer to the graph. So g prime of 0, we'd look at it at 0 and draw a tangent line. That's a horizontal tangent line. So g prime of 0, which is 0. So that's going to be equal to 0. So k prime of pi equals 0. That is our m tan. That is okay. It is okay to have a 0 sloped tangent line. There's plenty of tangent lines that have a slope of 0. So that is okay. It's fine for us to have 0. It's usually one where we would look at it and say, I don't know if that should be correct. Can I go through all my work again and make sure that I didn't make any mistakes? But at the end of the day, I got it. And then the point. Do we have the point? It didn't give it to us, so we must be able to find it somehow. It tells us what the x value is, so to find the corresponding y value to k, we plug in pi. So x equals pi implies k of pi is g of sine of pi. But sine of pi, which we already know, was 0, so this is equal to g of 0, which based on the graph, that's the function value, not the tangent line, but the function value at 0. So I'm going to have to scroll up to where I'm coming right back down. G of 0 is 1. So G of 0 is equal to 1. I'm gonna come, I'll come back up to the graph. I'll zoom out so that the graph is present. Hopefully, I'm sorry, that's really small, but hopefully you guys can see it. If you need me to zoom in at all, just let me know. But G of 0 is the Y value of the function at x equals 0, which would be 1 in this case. Because every two little hash marks represents 1. So when we plug in pi, we got 1. So we have the point pi comma 1. Yeah, it's a weird point because it's got a pi in it, but I mean, I'm weird. So it's okay for us to have a weird point. So using the better version, y minus 1 is equal to 0 times x minus pi. But that's just going to be y equals 1. This is the only situation where I'd be okay with you writing it in slope-intercept form. Either way is fine to me, though. A cool problem. Cool problem. Do you agree? Yeah. There we go. See inside your head, you're thinking this is way too cool. You just don't want to be, you don't want to show it outwardly too much. I get it. I changed that for my alarm in the morning because I did not like that sound. Okay, last one. So suppose f and g are differentiable functions with the following information. A lot of information. F of 1 is equal to 7, f of -3 is equal to 1, g of 1 is equal to -5, g of -3 is equal to 2, and f prime of 1 is equal to 10, f prime of -3 is equal to 2, g prime of 1 is equal to 5, and g prime of -3 is equal to 18. Cool. So just as a note, when you're reading this problem, notice that all the first ones are evaluating the original function, and the second set of terms are evaluating the derivative. So when you're deciphering this information, try and isolate it in your mind. I did that deliberately so that it was separated in that situation. Some textbooks will like to jumble them around. So like f of 1, then f prime of 1, then f of -3, then f prime of -3. So just be aware of that. It's a very, very similar situation. K of x is equal to g of f of x. So if we want to find the equation of the tangent line, we need a slope first. K prime, by definition, is g prime of f of x times f prime of x. We're not given anything about the functions, so we must have to deal with it purely in terms of the formulas. So the chain rule. So when x is equal to -3, k prime of -3 is g prime of f of -3 times f prime of -3. So now we have to do a bunch of definition chasing. Not definition chasing, but point chasing, I guess. So f of -3 is 1. So this is equal to g prime of 1 times f prime of -3 is 2. And g prime of 1 is 5. So this is 5 times 2, which is 10. That is our mtan. Does anybody have any questions on that? We can do hard things. All right, that's the slope. And then the point isn't given to us. We only have the x value, the x coordinate of the point. So for the point, when x is equal to -3, k of -3, that's our y value, would be g of f of -3. So that would be g of 1, and g of 1 is -5. That's why I wanted to make sure you to mention that at the very beginning. The first set of function values are all the function itself. The second set of values are the derivatives. So we know which way where to look. You can underline it too if you want. So we have the point -3, -5. So y minus -5. So y plus 5 is equal to m tan 10 times x minus -3. So x plus 3, just the correct version. Or y equals 10x plus 30 minus 5, so plus 25. Okay, any questions on that? Johnson & Johnson, no tears? No crying? Now that we've seen those types of problems, if you ever see one where you're not given a function, try to appeal straight to the definition to understand it. And don't be afraid to write something down. I don't know who heard us in math to think that we had to be right whenever we wrote something down. We don't have to be. When you're writing an essay, do you have to write the exact right sentence at the very beginning? No. I still struggle with that, to be fair, to be clear. When it comes to English, I don't know how to start a paragraph. It always drives me nuts. But after a while, I just write down gobbledygook and then eventually edit it and say, I'll deal with it later. And so the same thing happens with mathematics. It's okay if we write something down that doesn't make any sense. We can erase it and start back over. So that's the end of this section, but I was willing, I wanted to maybe go over some of these practice problems. I really have a temptation to do number 4, but I do want you guys to try and experience it yourself and experience the frustration and the delight when you actually figure it out. It is once again, if you can figure that out, then you are in good shape. You know what, let's do 3A or 3B or 3C. What do you guys want to do? C? All right, let's do 3C. Let's add on a page. So I'm going to rewrite it so I can, so y, God, could you imagine if I just always wrote my notes like this? You read that? So y equals e to the x cubed plus 2 over 3. We'll bring that down. We're trying to find y triple prime. The first thing I'm going to do, I did this deliberately on this problem to remind us that a temptation might arise to say, oh, that's a quotient. It's not a quotient. It can be a quotient, but you'd be putting yourself through way more work than you need to. Instead, rewrite this as 1/3. One-third e to the x cubed plus 2. Makes it way simpler. If you try to use the quotient rule, you're not going to be wrong, but you're going to be taking it's going to make it way more complicated. I did this deliberately to show you, when you took the derivative, you'd be like, whoa, that's really, really excessive. Maybe there's a simpler way. So y prime, 1/3 e to the x cubed plus 2 times the derivative of the inside. The outside function is e. So then this would be 3x squared. So as a reminder, we're going to be finding the third derivative. So we need to use our first derivative. So we should simplify it. And it does simplify quite nicely. It simplifies to x squared e to the x cubed plus 2. Because the 3 and the 1/3 cancel. That was nice of you, Phil. I know, thank you. Thank you for saying that. I appreciate you noticing the generosity of getting that 1/3 canceled right off the bat. All right, now to find the second derivative, it's going to require a product rule. This is our f. This is our g. So f prime should be 2x. G is e to the x cubed plus 2 plus g prime, which would be e to the x cubed plus 2 times 3x squared times x squared. F prime g plus g prime f. And so we're going to be using it to find the third derivative, so we need to simplify it. We should simplify it. And that will be 2x e to the x cubed plus 2 plus 3x to the fourth times e to the x cubed plus 2. Now, to find the third derivative, we could go through right now. It is simplified, but there's a faster way. Because right now, we'd have to do two product rules. So we have to do a product rule in the first term, this one right here, and we have to do a product rule here. But we can simplify our work by factoring out an e to the x cubed plus 2. If we do that, e to the x cubed plus 2 times 2x plus 3x to the fourth. Now it's only one product rule. Is it wrong to do it the other way? Absolutely not. You could do it. 100%, it's fine. I'll give you full credit either way if this is a problem on the exam. But just as an observation that you can mitigate the work that you have to do. So from here, I think you guys can try and find it. I'll slowly fill in details. That should be your answer. Any questions on that? I like this one just as a reminder that we should simplify if we're going to use it. If we're going to use our derivatives or any of our things that we're working with, if we're going to use them, simplify them. Otherwise, leave them unsimplified. No need to waste precious brain space. Any questions on that? By the way, so we are done with today's lecture, by the way. So if you need to leave, if you want to leave or whatever, that's fine. But I'm going to keep doing some extra practice if you guys want it. Is there anyone here that you guys are interested in? Number 7's pretty nasty. You guys want to do 7? Or do you want to do number 1 or 2? 7? All right. So g of x, I'm going to right off the bat, I'm going to rewrite this as x squared plus 3x minus 4 to the 1/2. And it's perpendicular to 4x minus 5y equals 15. And we want to find the equation of the tangent line that's there. All right. So we want to find the equation of the tangent line that is perpendicular to here. In order to do that, we need to find the slope. So since our curve is perpendicular to that one, we can find the slope of the tangent line immediately by doing this. So that's the same thing as saying negative 5y equals negative 4x plus 15. And then we'll divide both sides by negative 5 to get y is equal to 4/5 x minus 3. So that line is perpendicular to our line. So our m tan should be the negative reciprocal. So this means that m sub tan is equal to negative 5/4. Okay. Not a very nice slope, but we'll deal with it. Deal with it. So we already found the slope. Good, but we need a point. And it didn't mention an x value or a y value. It didn't mention a point, didn't mention an x value, didn't mention a y value. So what are we to do? Well, we know that the tangent line, its slope comes from the derivative. We already know what the derivative's tangent line is supposed to be. Like we already knew what the derivative's value is supposed to be, so we can solve for x in that equation. This has to equal g prime of x. So we can solve this equation. G prime should equal -5/4. But in order to do that, then we need to find g prime. So g prime of x is equal to 1/2 times x squared plus 3x minus 4 to the -1/2 times 2x plus 3. Now, here's one of the situations where I recommend being able to convert backwards and forwards between radical and unradical form, because I find that it makes more sense to look at this in radical form. I bring that up so when you're stumped on something, maybe trying to look at it a different way might help you out. So I'm going to rewrite this, and I'll show you why. I'll show you why. So if I have this, don't write this down. This is my first draft of how I approach this problem. When I look at it this way, it looks a little daunting. I'm not quite sure how to solve it right off the bat. So what I do instead is I rewrite it the way that might make it look nicer. So I write it this way. 2x plus 3 over 2 times the square root of x squared plus 3x minus 4. That looks a little bit nicer. So we have 2x plus 3 over 2 square root of x squared plus 3x minus 4 equals -5/4. And that is what we call a radical equation. And so we can solve it. We should cross multiply because it's a fraction equals a fraction. So we end up with 8x plus 12 equals -10 square root of x squared plus 3x minus 4. And we could simplify a little bit. We could divide by 2. I think we should, but we don't have to. You guys want to divide by 2? Or no? Do you think you would have remembered to divide by 2? No? That's okay. If I was I'm going to do it as if we were on an exam scenario where our mind is trying to work a mile a minute. And so we don't necessarily notice that there's a common factor of 2 that can be factored out. Is it going to change much? No. It's just going to have we're going to end up dealing with smaller numbers. But either way, I need to add in an extra page. So when I'm dealing with this is a radical equation. The way you solve a radical equation is you get the square root on one side of it so that you can square both sides. And that's what we're going to do. So we get 64x squared, 8 times 12. I don't know off the top of my head. 96. Do I have it memorized? Hell yeah. Hell yeah. All right. But then you got to multiply by 2. So that's 192. So plus 192x plus 144 equals 100 times x squared plus 3x minus 4. Or preferably that's 100x squared plus 300x minus 400. I know they're large numbers. They're people just like you and me. We don't need to be scared of them. So I'm going to bring everything to the right-hand side to make it easy, so that my leading coefficient is positive. So I get 0 is equal to 36x squared. 300 minus 192 is 108. So plus 108x. And then 400, so minus 544. Now, we could go through, does 108, can you divide it by 36? You can. Can you divide? Nope, you can't divide all of them by 36. Might as well just use the quadratic formula. I mean, you can go through and have a ball and factor it if you really want to, but I would just say, let's use the quadratic formula. X equals negative b, so negative 108 plus or minus the square root of b squared, so 108 squared, minus 4 times a times c, negative 544, all over 2a. So that's going to be two different answers. Let's go ahead and find them. Negative 108 plus the square root of 108 squared minus 4 times 36 times negative 544, all divided by 2 times 36. And you get 8/3. Good, 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 good. We got it like as the hint suggested, we should get somewhat nice numbers. If we didn't get it, like if this was starting to become like an irrational number, I'd be a little bit concerned, but it's not. And then the minus gives me negative 17/3. Oh, and that's enough for now. I don't want to get us any later than that. But what I will tell you after this point is that when you squared this equation, you have fundamentally changed it. So you end up being that one of these solutions, one of these things is an extraneous solution or a not right solution. It doesn't work. I believe it's the negative 17/3, but I can't remember. Maybe it's the 8/3. Actually, I think it should be the 8/3 that doesn't work. The negative 17/3 will work. But anyways, check these ones and you should get from there. One of these doesn't work. All right. That'll be it for today and for this week. So if you have any questions, feel free to email me. Otherwise, you guys have a great rest of your day and a great weekend. And I will see you guys on Tuesday. See you then.